Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host, Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a really good friend to the universe. I think about it every day. And I'm recording here from my office at Pale Blue Podiversity, and I'm expecting an exciting return guest, someone I've wanted to have back on the pod for a while. Mayanna Berrin is a comedian, a voice actor, and a writer for animation and video games, and she should be here any minute now. Mayanna, welcome. Come on in.
Oh my gosh. Wow. This looks so good. This is exactly what I pictured as well. Thank you so much for having me.
Thank you. Yeah, I think that when I'm walking around out in the world, people can tell that I like a cozy space.
I too love a cozy space. So this is exciting to me.
Mm-hmm. Especially since, the weather is warming up.
Not from where I am. It's raining. It's gloomy. It's cold. It's been spooky. It's been there was like a heat wave for like 2 days and then it got real cold.
Oh no. So you're staying inside, I hope.
Staying inside. I have what I usually use for my, lady problems, my lady cramps, this little heating pad for my lady cramps for my lady time. But I've been using it just to not freeze to death.
It's multi-purpose.
Yeah, it's funny. Sweet Misha has a space heater, and they did warn me of the energy, the voltage, and I have since been hesitant and procrastinating on buying a space heater for myself. I probably should just get one. But I have not yet, so I'm in my spooky cold apartment most of the time. But not here. Here is cozy and lovely and warm.
It's so warm. We're sitting on the plushest of chairs.
Oh my God, it's the best.
It is. Well, how have you been since we last talked? Since we last caught up on space news?
Oh my God, that was so much fun. I've been well. It's interesting. As a creative, I'm sure you have these ebbs and flows times where it's very exciting being a creative professional, but it's also very interesting because all of the things that I think other people see as just an escape from their, daily lives is my daily life. So it's like, how do you disengage from television or entertainment or video games when that's the thing that you think about as your work?
Yes.
Yeah.
So what do you do?
Oh my God, great question. I don't know. Lately, I have this kind of category in my brain called in case of emergency break glass. And so for me, Severance has been in case of emergency break glass. I've just been saving it. I don't know why. I watched season 1 and I really liked it. And so I finally watched episode 1 of season 2 last night. I'm like,
nice. There's
like 8 episodes out as of the moment we're recording this. And I was like, okay, cool. Like, why did I wait? Why did I wait to enjoy the thing? I think I have these times where, I'm going through just working a lot and being very stressed. And I feel like I save my fun thing. I'm like, for when I'm really sad, you know what I mean?
Right. And your fun thing is Severance.
Yeah, I know.
But I think that makes sense, right? Because when you are doing your voice acting and your game writing work, I imagine that's pretty speculative and very different from what you're seeing in this show.
Oh, yes. Oh, very much, very much. And I also think it's kind of interesting because there's a tone to everything, right? And so the video game, which the title has been released, it's called Dispatch. The game is not out yet, but we announced at the Game Awards. And so it's about superheroes and it's very comedy focused and very snarky. And so that's a very particular tone. And so being in that tone during the day and then disengaging and being in a different tone when I play TTRPGs, for example, or when I am, working on personal projects, different things like that. You start to kind of compartmentalize, kind of like the islands and Inside Out. It's a lot of I'm in this island right now, that kind of thing.
Yeah, I think I do something similar where I spend most of my time thinking about space and other planets and what life might be like on them.
Oh my gosh.
So any type of sci-fi feels like a lot of work to me, which is why I consume basically none of it.
So are you very into grounded human interest stories?
Nothing too real. I like reality TV and I like
reality
fantasy
TV
stuff.
Yes.
Yeah. Since you were here last, have you experienced a change in your relationship to the universe or the way you think about space?
Oh, that's a great, I mean, I definitely have thought more about space since being a lovely guest on this show. And I've been getting fed, I don't even remember the name of the account, but on Instagram, I've been getting fed different like nebula photo things.
It knows.
Yeah, I know, it does. And I find those really interesting. And the idea that like, that there are certain anomalies that are meaningful in that they just are happening chaotically and unpredictably, but are very beautiful. I think there's just like, I've been thinking a lot about that. And just in general, I mean, I've always had this sense of balance, like that there are times where things are out of or off kilter and then they get back on kilter. And that's just sort of the nature of the beast. Also, have you ever listened to the song Not Perfect by Tim Minchin?
No.
He's a comedy songwriter. He wrote the Matilda musical.
Oh.
But he has a song called Not Perfect, and it's about like he goes from Earth to his house, to his body, to his brain. And the part about the Earth, which I thought was so interesting, is like it's rotating at all through space at rather an impressive pace and doesn't even mess up my hair. It's just like such an interesting like concept of like, yeah, we forget how small and silly this all is, and any opportunity we have to settle in that for a second when things feel like they're really big and impossible is important. And so I feel like that perspective was very much gifted to me by you. So thank you for that.
Oh, thank you for that song choice. I'm really sitting with the scale of thinking about all of the motion that Earth is doing through space so that it doesn't even mess up your hair. And I'm like, wow, she protects us
really
like
out
that.
here.
Yeah. And by she protects us, I mean, you know, the lack of acceleration protects us from feeling a force that makes our hair move.
Isn't
you know,
that
it's
wild?
really beautiful.
And yet we also have wind.
And that's a completely different mechanism.
It's so crazy. Wind is one that I do every once in a while. I'll just be like, damn, that shit's crazy.
Imagine being the first person to figure out what wind was.
Bro, I like, how would you even, like, who would you go to? Who would you shake? Like,
you shout it to the wind.
Yes,
you go on a tall structure
oh,
and you scream into the gust.
it's happening. It's happening right now.
I'm so glad to hear that, that you've been thinking about space more and that it's like opened this other avenue of thinking and perspective.
Have you had
exactly
any
what I wanna hear.
revelations lately about space? Anything new that you've been thinking about?
Oh, I don't know about new. I've been revisiting some.
Yeah, what are some
thoughts.
themes that are coming up?
You know, the last few months have not been easy necessarily, and so I have spent a lot of time, you know, looking inward and outward to the universe and being like, why? Why are you, what did I do? What did we do? Why are you doing this to me?
Why hast thou forsaken me?
Yes. And then, you know, I have to remember that the universe isn't that type of friend. Like it's not the type of friend who is going to make sure you have a good birthday or like make sure you get to your job on time. Like it's not a service friend.
Oh, dang. Yeah, I feel that very strongly. I don't know like what your general friendship maps look like, but yeah, there are some friends where I'm like, they're good. Like they can handle their stuff, and if they need to talk to me about anything, they can. And if they need to talk, like if I need to talk to anything about them, they can. And then there are some friends who are a little bit more in need, right? They just need more accommodations or just more time or more conscious thinking. And I think like that is so interesting that the universe is one of those people who's like, I can't do that for you. I need you to figure it out. I'm figuring out stuff you wouldn't even freaking understand. I'm out here making all these nebulas and whatnot. And you're over here trying to figure out if your PTO is going to work or not. Like, yeah, we are not the same.
We're not the same. Exactly. So yeah, when I put myself in the universe's shoes in that way, it's like, oh, okay, that's why you're not giving me easy times.
The universe
because
is
one, you
everyone's
can't,
mom.
and two, you don't want to.
It's everyone's like frazzled mom who's like, I'm trying to feed this family.
Can you just appreciate me? Mother's Day comes but once a year.
Exactly.
And there's no universe day.
There's, you know, Man, okay, if you had to pick a date on the calendar, what would be Universe Day?
I feel like it should be a time when we have a good view of the universe.
Okay.
But that's more location than time-based. I don't know. I'm just going to say it's in the summer. I'm just going to say...
I feel like that's right. It's like the middle of the year. I feel like it's got to be like right smack dab, like whatever the middlest day of the year is. Because if it's so hard because we have 365. And so it'd be like 100 something, 20 something. I'm really bad at math.
Let's just say that the Universe Day is the day after your hemisphere's summer solstice.
Oh, I like that. So it's
either
different.
June
It's
22nd or December 22nd.
Amazing. So in Animal Crossing, you'd have to pick that. You'd have to pick your hemisphere.
Yeah. Yep. Well, shouldn't you do that anyway?
Well, you know what's so funny is they used to not make you, but in New Horizons, they're like, what's your hemisphere? And then you'd have spring at a different time depending on what you picked, which is really cool.
Yeah, I think if you're talking about farming, you should know what hemisphere you're in.
100%. Absolutely. Sorry, we went on off such a detour tangent.
It's okay. I think it was all relevant. Well, I at least had a good time, and it's my podcast,
I did too.
So
yeah.
it stays. I have a couple other questions that I've been asking people since you were on the pod. The questionnaire, the prelim exam has updated.
Ooh.
Just a couple.
Okay.
What's your favorite unit of measurement?
Oh, my God. Ooh, I don't know why, but my brain said kilometer, so I'm going to trust that. Maybe it's just because, so in comedy, there's certain sounds that are funnier, and I guess overall, the funniest kind of consonant is the k. I think there's just because there's a lot going on with it.
Yeah, it's guttural.
Yeah, it's got a lot of emphasis.
Got to get the back of the throat involved.
Exactly, so I think kilometers. I have no other reason besides that.
Sounds funny. Interestingly, a lot of the people answering this question have been giving me units of distance and length.
Oh, yeah, because it's like, I think that's the one that we probably think about the most. Because like tablespoons are like liters. I don't know why, but like unless you're cooking, I typically don't think about the world in those terms, which is also interesting. Like, why? Why is that?
Why?
Oh,
yeah.
Why?
Okay. The kilometer. That's a good one.
Thank you.
A good old metric system.
I know. I don't even. I live in the U.S. I don't know why I care so much.
No, it's the better system.
That's what I hear.
We have the good temperature system, but everything else, they win.
Oh, you hear that, UK listeners? I don't know.
My next get to know you question is, if you could see in a different part of the electromagnetic spectrum, which one would you choose and why?
Oh my God. Okay. Because I'm your little dummy comedy friend. What are the other ones?
Oh, yes. Okay. You're not dumb.
Thank you.
You're not.
Thank you.
There's going down in terms of energy. So getting longer wavelengths, you have the infrared and you have the microwave and then radio waves. And on the other end, with higher energies and shorter wavelengths, you have the ultraviolet and then X-rays and gamma rays.
I would say ultraviolet. Absolutely. I don't know why. I feel like there's a lot of colors going on in there. I could be wrong.
Yes.
Okay, cool.
Yeah.
Okay.
Plants and a lot of animals, just nature in general, looks really cool in the ultraviolet.
Yeah.
There are those flowers that have really cool ultraviolet patterns on them that like only bees and other pollinators can see.
That's what it is.
Yeah.
That's why.
Yeah, you could commune with the pollinators.
I'd be like, girl, I get it. I'd nectar up that baby too.
You're like, yeah, I can't blame you. That flower's looking pretty fine.
That flower's looking real nice.
I like big petals, and I cannot lie.
Oh, I want that T-shirt. Because I feel like it'd have a nice, like, hand-drawn rose on it.
Yeah.
And I'm a sucker. If there's a hand-drawn rose on anything, I'm like, do I need that? I'm like, Mayanna, stop.
Noted.
Yes. Oh my God.
All right, that's a good answer. And you'll be able to see a lot of newly formed stars, although a lot of ultraviolet light doesn't make it through the atmosphere, but some does.
Oh, I'll be like, hey guys, you see that? You wouldn't understand.
You would be able to see when you really need to put on sunscreen.
Ooh, I do need that because I always forget. We're melanated. I'm like, what do you mean? I'm like, no, Mayanna, you got to protect your skin. Protect your skin.
I know, it is a lesson.
Yeah, it's true.
We know about lotion. We learned that from a young age, but the sunscreen doesn't get taught
I'm like,
to us.
Tee-hee. No, come on, girl. Get with the program.
So a couple weeks ago, or a few weeks ago, sometime in the past, I reached out to listeners, mostly on Instagram, a little bit on TikTok. I told them to email me with questions. I wanted to know what they wanted to know about the universe.
Oh my God, this is so exciting.
It is so exciting because when I make a new episode, I think of a topic and I explore it as deeply as I think is interesting. But it's really nice to hear from the listeners what they want to know about. So I compiled about 10 questions from listeners here, and I would love to go through them with you. And you also, please feel free to add your own questions. Ooh. And if anything is unclear, let me know.
Absolutely. Okay, so we've got our first one from Laura.AmyDW. I hope that's an Arthur reference. I love Arthur. That's all I care about. How does the North Star work? With Earth's axial tilt and moving around the sun, how does one star stay in the same position?
Mm-hmm. If I recall correctly, they asked this question and prefaced it with like, this is probably a stupid question. Aww. I'm like, no, actually it's not, because that is a hard type of orientation thing to have in your head. Do you have a good idea for how the North Star works?
Oh, gosh. Okay. Because the North Star, it's part of the Big Dipper, right?
Currently, yeah. It's a star called Polaris.
Polaris. I mean, I think it's probably because for whatever reason, the positioning of the Earth, it's like closer to the axis. And so it doesn't perceive to be moving as much because, oh my God.
Yes, exactly. We call it the North Star because it's the star that our North Pole seems to be pointing at. Wow. Like our North rotation pole, not necessarily our North magnetic pole, but they're so very close.
Wow. I knew a thing. That's so exciting.
So the question here was, why doesn't the North Star change as Earth goes around the sun? If it's like, pointing in different directions, and if we're in a different spot, shouldn't we be pointing to different things? And yes, technically we are pointing to, kind of different spots in the sky as we go around the sun, but we're always pointed in like roughly the same direction.
Wow.
And that direction currently points to Polaris, which is about 430 light years away. And because it's so far, our pointing can be a little messy. Like we don't have to be perfectly precise, which is good because our pointing is going to be very messy because it changes over time. The Earth's axis wobbles a little bit. Scientists call it precession. So kind of like a top spinning. And then
Inception.
At the end of its... Yes. Yeah. Inception. Or if you've played like little top spinning games.
Like Dreidel.
Yes. At the end of its spin, you can see that it starts to wobble a little bit, and Earth is doing that too. So the wobble means that at different times, the North Pole is pointing at different stars. And it does that cycle every 26,000 years. And it over that time points to like 14 different stars.
Wow.
So Polaris is the star right now, but in about 1,000 years, it's going to be a different star called Gamma Cephei. And like 3,000 years ago, when ancient Egypt was going strong, there was a star called Tubin that was the North Star. And it's just going to cycle through all of those.
And Tubin famously wrote The Run of His Life, a book documenting the O.J. Simpson trial. That is a Jeff Tubin reference for the
star
Jeff
was
Tubin.
Probably named after him.
Yeah. Oh, man. Well, what's so funny to me is, so sorry, what's the name of the star that's waiting in the wings?
The next star is going to be Gamma Cephei. That's its like official name. It has a different name. Arii, but I didn't know how to pronounce it.
Well,
so.
I picture just like that. Have you ever seen the show Smash, where the two ladies are going into audition for the Marilyn Monroe part? It feels very that. It's like Polaris over here, Gamma 7 or whatever it is you just said over here, yes. And they're both ready to be like, "Let me be your star," which is also the song that they sang at the end of the first episode of Smash.
Ooh. Yes, it's exactly like that. But there are a whole bunch of other stars waiting at the wings to be like, no, we're coming for you next.
Yeah, we're coming for your number. We're ready to be the one you point at. It's so interesting to think about the fact that like, obviously the Earth is going through a lot of shifts and has always been, but that there will be people who know a different North Star, and that like what will the rest? What else will be different by then? We won't know. We won't be here to find out, and that's interesting too.
Yeah, we won't know for sure, but they'll have slightly different constellations, which will be cool.
That's wild, because certain stars will have faded by then.
Certain stars will have faded. The stars themselves will have shifted around, and from due to precession, like our perspective of the night sky is going to shift ever so slightly.
Wow.
There are simulations that I've seen of what the constellation Orion looked like thousands of years ago and will look like in like 5,000 years.
You skipped leg day.
it morphs. It really does. Like just the stars move.
That's so
it doesn't look like Orion anymore.
To think about. I think I said this last time. I was like, I can't believe we don't just sit around and think about this all the time.
It's true.
How can we think about taxes at a time like this?
You can just tell the IRS, I'm sorry, I was thinking about space. Like,
and they're like, we get it. All right, fine. Your taxes are revoked for the year. We get it. All right, we've got _stardust_kitties on Instagram. If we were to build a colony on a moon in our solar system besides our own, which one should it be? That's so interesting.
It is.
What does Stardust Kitties know that we don't know?
Yeah, why are you trying to get?
Why are you trying to build
somewhere?
A little colony? What's going on? What should I? Why are you leaving?
And how are you getting there?
Yeah, big question.
Real question.
That's the big question.
My real answer is that I don't think we should. I was actually on a panel yesterday where a high school student asked me what I thought about planetary exploration. And setting up like bases, exploratory bases on other planets. And I was like, in theory, I think that sounds awesome.
Yeah.
I love the idea of space exploration, but I don't think we are ready for that yet. If we go out there, it's going to be space colonization, which I am not comfortable with. So my real answer is I don't think we should set up a colony on any moon or planet or anything.
Ooh.
But
if we had to.
I'm not going to leave you hanging. I'm not going to leave. I will give you an answer.
Yeah, Stardust Kitties needs to know.
Mm-hmm. If we were to put a colony on any other moon, it should be Titan.
Titan?
This is the second biggest moon in the entire solar system. It's a moon around Saturn, and its atmosphere is kind of the closest to Earth's that we see out there in the moons. It's mostly nitrogen. Earth's atmosphere is almost like 80% nitrogen. So there's a similarity there. And they also have liquid lakes and rivers. They're not water. They're methane and ethane lakes.
But liquid methane?
Liquid methane.
Is that a thing we know or have seen in on Earth?
We can make it here.
Oh.
It just requires a lot of pressure. So the atmosphere has a similar composition there, but it's much denser. So the pressure on the surface of Titan from its atmosphere is about 50% more than the pressure here on the surface of Earth because their atmosphere is really dense. But that also means it's easier to fly through its atmosphere. I used to do this gig where I acted as like a travel agent to other planets in the solar system.
So fun.
It was a lot of fun. I had a little hat.
Did it have like a little Earth on it or something?
No, it was pink and it said, what was it? I think it was like the Interplanetary Travel Bureau or something.
So fun. Sorry.
It was based on a book where two astronomers got together and wrote a book about different moons and planets in the solar system and said, like, if you were a tourist there, what would you do?
I love it.
And one of the big attractions for Titan was that you could do like hang gliding, like really extreme hang gliding in the atmosphere.
That rocks. That rocks.
Yeah. But overall, not good for us. And we are planning on sending a little like helicopter thing there to Titan in 2028. That's when it's going to launch, hopefully. It's called Dragonfly, and it's going to fly through Titan's atmosphere and analyze the composition.
Oh, good job, Dragonfly. I hope it goes okay. The thing that I always think about with like space colonies and like living on another planet is the amount of like extra stuff you'd have to do to like get through your day. And I think that that's so wild, like that people are like, yeah, it would be so great to live in space. I'm like, no. All the like lack of oxygen, all the like, we got to take care of what we have here. We figured it out. It's nice here. We like it.
Yeah. imagine living on the frontier in the 1800s.
I don't want to, and I won't.
You don't, right. I don't want to do that. That's the easiest version of what you would get to do if you tried to live on Mars or somewhere else. Because not only are you making everything from scratch and you're in like extreme survival mode, but you have to like care about the oxygen.
Yeah.
You know, you have to do so much extra work.
I also think, like, you know, for the layman, it's like, what are you going to be doing in space that you're not doing here? What, you gonna watch TikToks in space? Is it like, is it that much more exciting? You're going to do VR in space? You're going to play Overwatch with your buds in space? You're not going to be out there in the field. You're an accountant. Your name's Greg. Like...
So right. When they picture their life in space, they are picturing Star Trek. They are picturing you live on a ship and there's like a holodeck and they have food that can instantly be created for you and you can go to warp speed. Like, no.
You're going to be in your house doing the stuff you do here.
You're going to be in your, it's not even going to be a house. It's going to be like a capsule.
Yeah.
You get assigned a small closet that is technically large enough for you to sleep in.
Those little tube hotels in like Japan.
Yeah.
No, you're not Captain Kirk, okay? You're Greg.
Sit down, Greg.
Yeah, sorry to all the Gregs. Sorry. You can't catch a break these days. All right, thanks, Stardust Kitties. We've got... Okay, this one's a little tricky. Okay, Ealjandrem. Aeljandrum?
Aeljandrum. I recognize... they comment on a lot of the posts on Instagram, so hello.
Yeah, Ealjandrum. If gravity is not a force, why is it called the force of gravity? Oh, you got us there, Ealjandrum.
This is kind of like a semantics question almost, or like a definition question, because you can get really picky about what you consider a force, and then based on some criteria, gravity wouldn't necessarily qualify. But really, this gets down to the difference between like Newtonian gravity and Einsteinian gravity, and like relativity and stuff. For Newton, gravity was a force, so kind of like a set of strings tying everything together and like having influence on all of the objects through this force of gravity. Einstein came along and said it's not that gravity is this thing that connects all objects with mass. It's actually just a consequence of the warped shape of space-time. So there's not like an action happening, but it's like just a natural consequence. All of the other fundamental forces of the universe that scientists have identified, the weak and strong nuclear force and the electromagnetic force, we have observed force-carrying particles for all of them. Like the electromagnetic force is carried by the photon, for example. It's a tiny particle.
I believe that George Lucas referred to these as the metachlorians.
Oh, yes. The force has its own force-carrying particle. Yeah. There's scientific precedent for that.
That's so funny.
But gravity is the only of the four fundamental forces that doesn't have one of those force-carrying particles that we've identified. We have in the standard model of physics space for it. Okay. We call it the graviton. Oh. And it could hypothetically be this tiny little particle that carries the force of gravity, but we haven't found it yet.
We know it's out there, and it has a name, but we haven't found it.
We don't know it's out there.
Oh, we don't know it's out there.
No, but
ghosts.
Like a ghost. When we observe gravity, we see that it functionally acts like the other forces. It can influence things over great distances, and it seems to have like a cause and effect, and there are time delays that you can measure. So it acts like the other forces, so we expect it to have that same type of particle behavior, but we're not sure. And that's one of the big open questions, I think, in like fundamental physics right now, is how does gravity actually work? We understand how it behaves and we understand its like impact, but we don't necessarily know what it is. So we call it a force because it behaves like one.
So from the semantics point of view, what would be the more correct thing to call gravity? Just gravity?
When you get deep into like relativity from Einstein, you might call it a field. You might call it like a tensor. I think that if you're not going to describe it as like an invisible string force that tugs on stuff, you would probably describe it mathematically, and you would consider it not as its own entity, but as an array of values in a space that tells you how strong gravity acts there, but it doesn't allude to the idea that gravity is its own being.
I'm just giving ammunition for the most annoying person you've ever met at a party who's like, it's actually an eladrium. It's really, if you want to think about it mathematically. But that is very
You're so
interesting.
Right. I hate those people.
I know. And now you heard it here first. And then everyone will be like, why did we invite Greg? And it's like, well, he's going to space next week. And you're like, well, that's great news.
I feel like if you're going to space on one of those long-term missions, you should get, to go a little wild. Like, you're not coming back.
Oh, yeah. Be annoying at a party. You're never seeing these people again. There is a liberation to being the annoying person at a party, to be so free, to know who you are.
Yes.
We should all be like Greg when you think about it.
Hey friends, Mayanna is examining the special infinity water fountain that I had the students from the metaphysics department install in my office. I think that's going to keep her interested for a little bit, so let me share some messages with you. The first is a thank you to all of my patrons. Actually, all of the people who support Pale Blue Pod financially, because I truly couldn't make the show without you. I'm an independent podcast, and I rely on support from listeners like you. So thank you all so much. I want to give a special thank you to my Sun-like stars, Scott Reynolds, Augustin, Tom T., Mark Mahoney, and Nicole Bartlett. Your million-degree coronas are all looking particularly luminous today. Congratulations. And I want to thank Lita. Lita is the first supernova to go off in Pale Blue Pod sky. If you want to support the show, but a recurring contribution on Patreon isn't for you, you can send your support through PayPal at the link in this episode's description just once. That way you shine bright and brilliant in the sky, and then you can fade away into the night. But if you do want to join the Patreon, you would hear your name on the show, you would make it onto my patron star chart, and you would get research notes for most episodes for $5 a month. Brighter tiers like my Sun-like stars get access to Pale Blue Pod at night, where I read bedtime stories in what I hope is a slow, soothing voice. So you can sign up now at patreon.com/palebluepod, but remember that the best way to support the show and help Pale Blue Pod grow is to send an episode to a person who you think would like it. Word of mouth is so powerful. Next, I want you to know that the show is sponsored today by Audio Maverick, a new 9-part documentary podcast about one of the most visionary figures in radio, Hyman Brown. Explore the golden age of radio through the life of this famous New Yorker, whose programs brought millions of families around their radios each night. Audio Maverick features archival audio and contemporary interviews with media scholars and podcasters. Learn about the birth of radio, the height of radio drama, and discussions with the new generation of podcasting audio mavericks that Brown inspired. As a podcast listener, you'll love learning about Nikola Tesla and the history of radio, plus hearing incredible clips of famous shows like Dick Tracy and Mystery Theater. Produced by CUNY TV and the Hyman Brown Archive, this series covers decades of history in 9 episodes. So subscribe to Audio Maverick in your podcast app now. That's Audio Maverick. That K is tricky. Don't forget the K. But it's brought to you by CUNY TV, and you'll learn a lot. So check it out. All right, I have another podcast recommendation for you before we get back to the episode. This is another show in the Multitude Collective, and it is a show that I personally listen to all the time. It's called Spirits. It's a history and comedy podcast focused on everything folklore, mythology, and the occult, told through the lens of feminism, queerness, and modern adulthood. Every week, mythology buff Julia and her childhood best friend Amanda get together to learn about a different story from mythology and folklore over drinks. So they talk about spirits while they drink spirits. I love it. That's everything from the mythological origins of major franchises like Lord of the Rings and Pokemon, to modern urban legends that they read from listeners who send them in, to a roundup of werewolf stories from around the world. They cover everything. You can start now with any of their 400 plus episodes that they've released over the last 7 years. There's so much to enjoy, whether you're there for analyses of mental health in mythology or advice from folklore, where Julia and I channel different figures from folklore around the world to answer questions from listeners. It's a good time. You can dive in at spiritspodcast.com or search for Spirits wherever you download your podcasts. And new episodes come out every Wednesday. So check it out. Okay, I think Mayanna is done playing with the infinity water. Let's get back to this conversation.
We've got this next one, Jess Dresch. That's a cool last name. Why do we say Uranus is 98 degrees one way and not 82 degrees the other way? Do we say that? I guess we do.
We do.
Wow.
Yeah, Uranus is my favorite planet because it has the most extreme obliquity. That's what astronomers call it,
Cool.
which is
Cool word.
the axial tilt of a planet. So Earth's obliquity is about 23 degrees. So I think the crux of this question is asking about orientation in space. Like, how do we decide which direction we count that obliquity in? Because we're talking about the full circle of options, right? Imagine a planet.
Done.
In the solar system.
Got it.
Great. A+.
I'm there. Yeah.
Imagine the planets are like in the plane of the solar system. So they're in that flat disk. And imagine a vertical line going up and down through one of the planets. We say that planets are tilted, that their rotation is tilted, and we measure that tilt from that vertical line. So Earth's tilt goes 23 degrees from that vertical line.
Okay.
You can move a potential like 360 degrees. Like you can do the full circle because in space, in science in general, we do like to kind of standardize which direction we're moving to. So all of the planets in the solar system, their obliquity is measured in the same direction.
Did there, what was the consensus? Or like what was the, they were like, yep, that one.
I don't think it was necessarily like they got together and they were like, we're going to do it east versus west. But it just kind of makes sense. When you look out at the solar system, most of them are pretty vertical. Like Uranus's tilt is extreme. So usually you don't even have to wonder about this. But so it's 98 degrees from the vertical in one direction, let's say clockwise.
Okay.
The question is asking, why don't we say that it's 82 degrees in the other direction? Because it wouldn't actually be 82 degrees in the other direction. It would be 262 degrees in the other direction because you would have to go almost the full circle if you went the other way.
Oh my God. Wild.
It's like, if you're starting in LA, you could get to New York by flying 5 hours east, or you could fly a long time. Right. Yeah.
That's
that's what we're doing here.
Whoa. Dang. So the reason we say it's not 82 degrees is because that's not the right number.
Right.
Wow.
It would be like 200 something degrees. This is also because we're defining it by the north pole of the planet. Now, if the north pole of the planet is at 98 degrees clockwise, for example, then the south pole of that planet is going to be at 82 degrees counterclockwise.
Okay.
But we're northern centric.
All this is occurring to me is that every planet has Santa, canonically, if you think about it, if they all have a North Pole. So Saturn has Santa.
And little gas elves.
Little gas elves. So just think about that, Jess.
Please.
That's my contribution to this very good and interesting science stuff. We've got Jack Bowler over email. If part of being a planet is its orbit, and rogue planets are just space daredevils speeding through space on their own with the music cranked to 11. Okay, I do like Jack. What makes them a planet and not a comet without a tail? Does a comet that loses its tail evolve to a rogue planet like an icy phoenix? Wow, what a story this question told.
I know. Music on 11.
Jack's just got to write his romantasy book about the interplanetary bad boys of space.
Yeah, you're right. This is a research question for a book project.
Yes.
That's what this is.
Who are the bad boys of space?
Mayanna, have you heard of rogue planets before?
I actually have not. Everything about this question I find fascinating. So yeah, what is a rogue planet?
A rogue planet is a planet that does not orbit a star.
Oh, that's sad.
It is very sad.
Dang.
And we think they're common.
Whoa.
There are probably tens of thousands of them out there, almost certainly more. But they happen when a planet forms around a star and then gets ejected from the star system through some sort of gravitational interaction with another planet or another star, but it gets flung out of the system. And so to answer your question, astronomers aren't lawyers. Back in 2006, we made a big deal about redefining a planet and knocking Pluto out because it didn't meet all of the criteria.
My boy just out here fighting for his rights.
R.I.P.
R.I.P. Pluto.
In planet.
Rest in planet. That's a shirt. If you don't have that shirt, get that shirt on your website. Let's go. Rest in planet. Yes, you heard it here first.
So one of the criteria for being a planet is that you have to orbit a star.
Dang.
But astronomers aren't lawyers. We are going to follow the spirit of the law and not the letter of the law. The spirit of the law still says that Pluto isn't a planet because it's not big enough. It doesn't meet those criteria. Rogue planets, they at least formed around a star and they meet all of the other criteria, so we still consider them planets. And they are a totally different thing from comets. Comets also orbit stars.
Okay, comets orbit stars, and also I believe one of the requirements for being a comet is that it has a tail, right?
Yeah, a comet is an icy chunk of rock that formed in the solar system and orbits around the sun, but it has that tail, which is a bunch of gases flowing off of it because they're being evaporated by the heat from the sun.
Dang.
So that is kind of characteristic of the comet. But the most salient difference between a comet and a rogue planet isn't the tail. Right. So like if a comet loses its tail, it doesn't become a rogue planet because, again, comets still orbit around stars.
Right. Okay.
The most salient difference between a comet and a planet is their size.
That makes sense.
Yeah. I don't know if we think a lot about the relative sizes of chunks of rock in space, but the biggest comet that NASA has found is only 80 miles across.
Oh, wow. Okay. And by extension, what's like one of the smaller rogue planets?
I'm not sure about rogue planets, but the smallest planet we've ever discovered, it does orbit a star. And we expect that rogue planets should be very similar to the population of starred planets that we've found. The smallest planet is Kepler 37b, and it's more than 2,000 miles across.
Yeah, that's a lot of difference. Dang. Okay, so as the last part of this question says, does a comet that loses its tail evolve to a rogue planet? So it can never get that big, huh? No matter how hard it tries.
Right.
No matter
it would have
how
had
fast
to get
it
that
flies.
big. Oh, I feel like you're about to write an inspirational song about this comet.
I know, just a little comet trying to be a planet. That's like a Pixar movie, I feel like.
It is. It could be a planet, but it would have to go back in time and do the work at the beginning. Becoming a planet, it's kind of like how a lot of parents think making their child successful will work. Like, you really have to put in a lot of effort at the beginning because you can't do much later on.
I heard this factoid a long time ago when I was preparing to go to college, which was that 50% of freshmen at Harvard drop out in the first year because of the pressure.
No. I don't. That is not true.
Interesting. Ooh,
Harvard has like
facts.
A 98 or something % graduation rate from freshman year matriculation.
Oh, okay.
They pride themselves on that.
Then maybe
they would work with a student so hard to try and, like, you can take some time off, you can take a semester off, but like, you're coming back and you're finishing this degree.
Dang. They're like, I'm not giving up on you, kid.
Yeah. Not because they care about you as a person, but because they don't want their scores to slip.
That'll do it. I think that, like, I can't even remember where I heard that. I feel like it was my administrator or something. They're like, well, And I was like, oh, okay. Interesting.
Oh, they were trying to scare you.
They were trying to scare me. That makes sense, though. I think that, like, there's so much expectation. And I think the same thing is true of planets, too, right? Like, not that they feel feelings, but there is this interesting, like, we rank them. We have these thoughts about, like, not just their viability, but, like, we have favorite planets. And it's like, what could I have done? What could I have done to be your favorite planet? And it's like, I don't know, have a better, like, livable atmosphere.
If you had just worked harder at the beginning to collect more iron and nickel, then you'd have an atmosphere.
Then we'd be talking about it. Then we'd have something come back to me when you've got more of those things. Oh. Everyone's out here trying their best. Even the rocks.
Even the rocks. And I think we should take comfort in knowing that we have a lot more control over our ultimate destiny than the rocks do. Like what a planet's fate is determined by what happens in its first million years of formation, mostly.
Wow. That's so interesting. A planet's fate. That's such an interesting, like, just descriptor as well. And like, to your point about just like our own destiny. Like, I don't know. I'm buzzing. My brain's buzzing. Thanks, Jack.
Great.
We've got Bella Stewart from IG. I have a fun space app on my phone that alerts me when the ISS is about to fly over. But this happens so randomly. Sometimes I'll see it 5 nights in a row, and then I won't see it for another month. Is this because of the ISS's orbit?
Yes. This is the International Space Station. Have you ever seen it going above?
I don't think I have. I've seen like little movements in the sky, but I assume that wasn't the ISS. I assume it was just a shooting star or something.
A shooting star or a plane or something.
It could have been a plane. It was probably just a plane.
Probably. There are a lot of those.
Or
and
Superman.
Only one ISS.
Oh, there you go.
I hope there are a lot of Supermen. I mean, like it's not like he was special on Krypton.
Yeah, he was just like a guy.
Yeah.
So that would be cool if there was more Supermans flying through the sky every once in a while. But yes, okay. So yes, I don't think I've ever actually seen the International Space Station. But yes, to Bella's question, what is the cause of this randomness?
It is mostly because of its orbit. So the ISS orbits Earth every 90 to 95 minutes, and it spirals from west to east diagonally across the Earth. So it's not going straight across a latitude line.
Interesting.
And yeah. So because it's at that diagonal angle, as the Earth rotates under it and it goes around the Earth, the pattern that it creates on the surface of the Earth is like this crisscrossed pattern. So it does cover most of the Earth. It doesn't hit like the poles necessarily, but it does pass over a lot of the surface. And to see it, it obviously has to be above you.
Okay.
But there's a relatively good chance of that because it does like 18 orbits of the Earth every day.
Now, question, why does it move? Is it a choice or is it just because of the nature of the object in space? Does it have to move?
It doesn't have to move. We could have designed what we call a geosynchronous orbit, where it stays above the same place on Earth as it goes around. But that is hard to do because you need to use fuel and special planning to make sure it stays there. The ISS is at a special point in space where it's relatively stable and it doesn't need to use a lot of fuel or maneuvering to move around. It either orbits the Earth or it orbits the sun with the Earth. I can't remember which one.
Okay.
But it's advantageous for it to orbit the Earth for fuel-saving reasons and because then it just gets more views of the sky per day.
And so is that the function of the International Space Station? Like, why do we have an International Space Station?
To do experiments in space.
Cool.
Not just astronomy experiments. They do medical stuff, chemistry stuff. They do cancer research. They do reproduction research. I just saw an article where they were trying to produce melanin in space.
Whoa.
Because the conditions up there are so different. Like microgravity is its own thing. The cosmic radiation up there is a lot higher than we have here on the surface of Earth. There are types of light like ultraviolet and X-rays that don't necessarily penetrate our atmosphere.
Wow.
So we're trying to study different things under those conditions.
Now, and my question too is like, as a compound or like as a material, like what is melanin? What does it look like? Is it like a metal? Like what is it?
Well, in the picture for the article that I read, it did kind of just look like some scabs on a petri dish.
I was like, it's literally skin.
It's like literally just the pigment.
That's wild.
Yeah, it's these tiny little flakes.
Follow-up question too. Did they ever get that couple out of there?
Nope.
No way.
I know. They were supposed to come back last month. We're recording this in early March. They were supposed to come back last month. But it was a SpaceX craft that was like, actually, no, we can't get them.
No way. Man, the amount of appointments. I'd be like, I'm still up here. They're like, can't you just get down?
If that happened to me and I came back and you didn't immediately offer me a lifetime supply of everything I could ever possibly need,
Yeah.
I'm doing something. I don't know what. I'm crashing out.
Yeah. How many emails do you think they sent? How many emails do you think they sent complaining before they just gave up?
100, at least. I think they lost count. Although all of the news articles make sure to say they do not feel stuck up there and they are not unhappy with their situation. Like, yeah, of course.
I'll bet they're thrilled. Dang.
Right? No, they're still up there. And they're passing over us multiple times a day.
So
you
Bella, you're getting
up.
those updates. You know they're still up there.
Yeah, so Bella, when you're looking up at the ISS, you can wave to Butch and Sunny. Hey, this is Moiya coming in during the post process. We have an update on Butch and Sunny. They did, in fact, return. They came down from the International Space Station on a SpaceX craft, and they landed on March 18th, 2025. I have since learned that they did not get any overtime pay for their extra 7 months in space or whatever it was, and they only got a little bit of hazard pay of $5 per day. They got $5 extra per day every day they were up in space. I don't know about you, but that would make me crash out. There's no way I spend all that extra time up in space away from my creature comforts and I come back and you give me $5 a day. That's not even minimum wage. What are you talking about, NASA? Anyway, I just wanted you all to know that. Sunny and Butch are back and they are not as rich as they should be. I hope they get the juiciest, the fattest book deal. Because, oh my God, they deserve it.
Yes.
And you're not going to see it every day because it's not going to be over you every day. But it also has to pass over you at the right time. The ISS doesn't emit any of its own light, so you can only see it if it's reflecting sunlight, which means it's actually really hard to see at night when it's on the other side of the Earth from the sun.
Whoa.
So the best times to see it are at dusk and dawn.
Oh, cool.
So right around sunset and sunrise.
That's so fun. And I love that Bella has an app that lets them know when it's up there, when it's passing over. That's so neat. Thanks, Bella. We've got Scott next. Scott Reynolds. Did we just get wildly lucky with timing on the first gravitational wave detection, or do we expect them to be common?
So we detected the first gravitational wave source in 2015 with LIGO, the Laser Interferometer Gravitational Wave Observatory.
Dang.
Cool
and
name. It was 2 black holes. It is a really cool name. It's one of the better acronyms in astronomy, probably.
What's the best acronym in astronomy? Now I must know.
Abracadabra.
That's real?
That's
You're not messing
one.
with me? Oh.
No. I did a whole episode about it. I'll send you the acronyms episode.
Please. Yes. Amazing.
LIGO didn't even make it onto the list because it's just run-of-the-mill average.
Messed up. But anyway, back to the question. Yes. Did we get wildly lucky?
Back to gravitational waves. No. LIGO came online in September of 2015. Literally within 3 days, they had detected and nearly confirmed the detection of a gravitational wave.
Whoa.
Source.
And
two black holes merging.
Okay, and we need to know that for safety reasons or just for research reasons?
Just for research reasons.
Cool.
These gravitational waves were predicted by Einstein with his theories of relativity back in 1915-ish.
Dang.
And so we wanted to prove or refute, right? And it turns out that he was right. And now we have a new way of looking at the universe. For about 400 years, from 1610, when Galileo looked up with the first telescope, to 2015, we only knew about the universe through light. That was the only form of information we had. And in 2015, for the first time, we received a new type of information about space. And that gives us extra texture. It's like experiencing the universe with a different sense for the first time.
That's incredible. I also it blows my mind every time you tell me that we're making massive discoveries, or that we're breaking new ground or discovering things that we just straight up didn't have access to before, as of a year when Glee was still on the air. That's crazy. That's bananas. Like,
you're right. They could have had an episode where Rachel and Finn sing about black holes merging. They should have done Black Hole Sun.
I was literally just thinking they should have done Black Hole Sun.
Oh, the missed opportunities.
I know. Thank you for bringing this to our attention, Scott. We've got Cheyenne on IG. Why is it so hard to take good pictures of the moon with your phone? Dang, Cheyenne.
Because the moon is gorgeous. And
she's
gorgeous. So camera shy.
She's so shy. And also, like, I think personally, I mean, like, well, because there's some fancy cameras that can clearly get like right up in there. Yes. But like, what I like about space stuff, at least that I can see with my human eyes, is that like I don't really feel compelled to take a picture of it on my phone because it won't really capture it. But why is it so hard? What's the problem there?
So I'm not like an optics person, and I'm not a photographer, but from what I can tell, there are two factors. One is that your phone camera has just like a way worse light collecting area than bigger, nicer cameras. So they're letting in less light, which means they're letting in less information and detail. So that makes images look washed out and leads to lighting problems. But I think the bigger issue is actually the focal length of these cameras.
Oh, okay.
So focal length is related to the field of view that you have. If you have a very short focal length, then you'll have a wide field of view, which means you're trying to take in a lot at once, and it's gonna look not as sharp. It's gonna be a little bit less detailed. If you have a long focal length, you have a very narrow field of view, so you're really like focused in on something, and you're gonna get a lot of detail from it. The average phone camera has a focal length of like 26 millimeters. For a good picture of the moon, you want a focal length closer to like a few hundred millimeters.
That makes sense. It's also really far away, narrower. Right? Like
it's really far away, so you want a much narrower field of view. And something that people might not realize is that when you're zooming in on your phone camera, you're not actually like magnifying the image. You're not actually changing aspects of the camera to make it better able to see far away. You're just cropping your image before you take the picture.
That's so funny.
Yeah. So, you don't actually get to magnify on your phone.
Dang. That makes sense. I mean, there's only so much a phone camera can do. And it does so many things well. Do we also need it to take pictures of the moon?
No.
Give your phone a break today.
Exactly. Lower your screen time and use
and look at the moon more.
Be present.
Yes. We also have a secondary question, which is completely off topic, but I love it. Can you really travel back in time by slingshotting around the sun like in Star Trek?
I wish, but no.
What are you trying to run away from, Cheyenne? What are you trying to fix?
Because in Star Trek they did this to go back in time. So where are you trying to go?
Yeah, where are you trying to go? What's going on back there? What do you know that I don't know? Huh?
But no, it doesn't seem possible to go back in time, especially not using these relativistic effects. I've done a few episodes on the show where I talk about what happens to your rate of time passing when you get really close to a gravitational field or when you move at really fast speeds. And that's all it can change, right? Like if you move really fast because you slingshot around the sun like they do in Star Trek, time will move slower for you relative to other people who aren't moving that fast, but that's not going to send you back in time. That just means that when you reconvene with the outside observers, you will be slightly younger than they expect you to be.
My under eye circles will be slightly less dark.
Yeah.
Well, I also imagine it's probably similar as like going through a different time zone. Like, is it at all where it's just like, yes, it is tomorrow, kind of. You know, like the sun is setting over here and it's rising over here. Like that's as closest to time travel I think we're gonna get from just physical travel.
Right. From what I've heard, you can go forward in time, but in tricky ways, right? Like stopping time for yourself or slowing time down by going really fast, but you can't go backwards.
Yeah. So I guess the real lesson here is you gotta just accept whatever happened back there. If it was a biology test that you forgot to put your name on the top of, if it was the talent show where you forgot your lines, it's gonna be fine.
These feel like personal examples.
They are, yeah.
Okay.
You got to pull from personal experience. But thank you, Cheyenne, for both of those questions. And now we've got Lien Sga It's LEIN.SGAH. Very cool. Very cool spelling. Yes, SGA. How isolated are we to the rest of the universe? Does what happens in other galaxies have any impact on our planet? Or should we care only for what goes on in the Milky Way? Wow, what a big question.
Yeah. Well, I think we should care about the whole universe.
I agree.
Yeah, but realistically, no. It's like the butterfly effect doesn't operate on intergalactic scales. Even though we're not very isolated as a galaxy, we have a bunch of small satellite galaxies that orbit around the Milky Way, like the Large and Small Magellanic Clouds.
Ooh.
About 2.5 million light years away is the Andromeda Galaxy, which is big and beautiful, a spiral galaxy like us. And together, we're all in a little group. We call it the local group of galaxies. There are like 40 to 50 of us, all gravitationally bound to each other.
They go to brunch.
They do.
They go to space brunch.
They're neighbors.
Yeah.
Mm-hmm. They have potlucks. They complain about each other, but if
Andromeda's
an
really
outsider
pissing me
comes
off
in
right now, she's too beautiful is the problem. That's really what it is.
That is her reputation.
We can never be her.
But we all want to be.
We all want to be her so bad. Oh my God.
But our little local group is also part of a bigger cluster of galaxies called the Virgo supercluster. And then above that, different superclusters come together to form what we call the Laniakea supercluster.
Gorgeous.
So we are very in community with other galaxies out there. And that's not a given, right? Astronomers have found some very isolated galaxies. There are parts of the universe that are huge cosmic voids where it's mostly empty. And the record holder for the most isolated galaxy that we've found so far is... Its name is this long stream of letters and numbers. I wrote about it in my book, The Milky Way, and I nicknamed it Macy because the first 3 letters are MCG.
The loneliest one.
The lonely little Macy.
The lonely little Macy.
Doesn't have any galaxies around her for 100 million light years in every direction.
Get Macy in a supercluster. Come on, guys. Get her invite her to the brunch.
She's so alone.
The commute. It's like living in Santa Monica.
Yes. She has to take a boat and then a bike and then a bus to her job.
I remember one time when I was working in Santa Monica and I was living not in Santa Monica, I tried to see how long public transport would take me from my job in Santa Monica to where I was living, which was Hollywood. It took me 3.5 hours.
Did you do it?
I did do it. It was like, you talk about the last mile problem. It was like, I think I took 4 different train lines. I think I had to go above and below ground. And then the closest like underground railway stop to my apartment was still like 5 blocks. So even it was the longest. I was like, I cannot do this ever again. But that's Macy. That's the light years.
Knew what it was like to be Macy for a little bit.
Just a little bit. We're all Macy sometimes. We're all like, hey, we're throwing a party. And you're like, oh, man, that's too far.
Yeah, been there, done that.
That's so
You want me
real.
to go to Queens?
Yeah, Queens! No. That's so funny. Well, back in the day when I'm a big Sex and the City watcher where it's like, to Brooklyn!
I mean,
can't move to
Brooklyn. If you're going to Brooklyn, that's at least 45 minutes on the train.
I know. I remember a friend of mine moved out of New York because they were like, I was just sick of having to like plan for the hours around like my event, because it's like if something was at 3, what that really meant was like I had to leave at like 10 in the morning and like do a bunch of other stuff, and like the travel around the travel is so interesting. But going back to Lien's question, so I mean, we're not isolated, we're very much not alone, we've got lots of superclusters. Should we care? Should we care about what's going on with those other... Should we care about Macy? I care about Macy, and I just met him.
Yeah, I think we should care about them from a sense of, I think it's good to be curious and have care for all of the stuff out there. But is it going to affect us? Absolutely not.
Oh, and then we've got another follow-up question. Prophecy about an asteroid hitting Earth in 2027. What are the odds of that really happening? Could what happened to the dinosaurs happen again?
Yes. I made this the penultimate question on purpose because I think it's been in a lot of people's minds lately. I'm sure you heard about that asteroid that just kept getting more and more likely to hit
I remember
Earth.
this was happening around the time of the pandemic, right? I feel like there was another one that I heard about a couple years ago.
Oh, I'm thinking of one that made really big headlines just a couple weeks ago.
Oh my gosh.
In January, February of this year.
Did not hear about that.
Well, let's talk about this 2017 thing first, because there are multiple stories going around about different asteroids that will impact Earth with different probabilities.
Whoa.
The question here is about one from 2017, but more recently, like in February of 2025, there was a different one that made a big stir.
Huh.
So,
okay, let's do it.
Talking about the 2017 one first, when you Google 2017 asteroid impact prophecy, or like whatever this person asked about, the first results are official looking pages from NASA CNEOS. CNEOS is the Center for Near Earth Objects. They like monitor asteroids and other things for our safety.
Yeah, of course.
We love them.
Yes.
So the first 3 pages are like those results, and it shows you a warning about an asteroid called 2017 PDC with a 96% chance of impacting Earth in 2027.
Wow.
And I was concerned. I was like, first of all, why didn't I hear about this? Second of all, why aren't more people freaking out? Third of all, what? And then I looked into it, and I opened the results, and the so-called press release that is the first result to come up was a hypothetical thought experiment that they used at a CNEOS conference. PDC isn't even a typical asteroid designation code.
So it's fan fiction. This is another book someone's working on.
Yes.
Oh my God. Stop writing books, everybody. Just kidding. Write your book. It's great. Write your book. I'm sure it's really good.
But don't write your book making us think that we're about to be hit by an asteroid when we're not. The PDCs actually just stands for Planetary Defense Conference.
Oh, hell yeah. Nice.
Because it was an exercise for them to do at this conference in 2017. And when you read the press release, there's a red font that says exercise only, and there are some anachronisms.
Sorry,
but it looks so real.
Heated. I get so heated about stuff like this because it's like it's right there. And you just have to use your eyes. And then it's like, no, I really want to be so stressed about something. And you're like, why? Just be stressed about something else instead. Don't tell us the rock's going to hit the planet.
People took that story and they ran with it.
Great.
As the
people want to
24-hour news cycle are wont to do. Yes. But that was all fake. So that was a fake impact prophecy. But earlier this year, in February, there was big news from NASA about the asteroid 2024 YR4, because asteroids are named after the year they're discovered, and then like how many have been discovered bore that.
So year 4. That's just like, it just feels like an insult. It's like year 4.
You're the 4th one. Don't get your head too big.
That's so funny.
So it made a big splash in the news because it was estimated that it had a 3% chance of impacting us in 2032. And over like a couple of weeks, the percentage kept increasing. It started at like less than 1%, and then it went to 2, and then it went to 3, and that was the highest alert level that they had ever had for an asteroid before. And so people were scared. A lot of people asked me about it in my real life. They're like, so do you think that asteroid's going to hit us in 2032? And I had a bunch of these conversations. Since then, like in the last few weeks, because science moves quickly sometimes, new data from the European Southern Observatory instrument called the Very Large Telescope, they put the probability with new data on this asteroid at 0.001%.
Great.
Yes.
Love that.
So it's not gonna hit us. But you don't see the news making a splash about that. You don't see them talking about the
big
take-back.
problem. That's my big problem is like, be scared. Be scared. And then like the thing that's scary isn't there anymore. And they're like, ooh. And you're like, no. Tell me when to not be scared. Because otherwise I'm just going to be scared all the time. And I can't afford to do that. I have a life to live. But on the last part of this question, could what happened with the dinosaurs happen again?
Great question. Yeah.
Yeah.
Absolutely.
Yeah.
There are a lot of chunks of rock out there in space. I think the thing that hit the Earth and killed most of the dinosaurs was only like 10 to 20 miles across. Like, it was not that big.
Yeah.
And there are bigger ones out there. when I was having conversations with people about this asteroid and it was at 3% and they were really scared, my response was very hopeful. I was like, no, I don't, even if it does like come directly at us, I think we're fine because of the DART mission and how successful it was. The DART mission was a test. It stands for the Double Asteroid Redirection Test, I think. And it was a project to try and push away an asteroid coming towards us.
Taking Bikini Bottom and pushing it somewhere else.
Just a little boop. A little like, asteroid boop.
No. Like a cat just batting you away. No. Get out of here.
And we did it. And it was successful. We tried it on an asteroid that obviously was not like coming towards us. Like this was not, we didn't need to do this, but it was a test. So now we know we can do it when we absolutely need to.
Wow.
So I firmly believe that even if this asteroid does come to us, we will be able to redirect it. What immediately followed in those conversations was less optimistic. Because I think that if we develop the technology to divert a really big asteroid, that's like a lot of firepower.
Yeah.
Right? Because realistically what we're doing is we're launching like explosives and we're using the explosives to redirect the asteroids.
That's what I was going to guess. It wasn't like a non-lethal form of force.
Well, it's not lethal to the asteroid. We don't want to blow it up into smithereens because we don't want the chunks to hit us.
Right.
We just want to push it away. But those same devices that are used to push away the asteroid could very easily be turned back to Earth and be lethal in that context. So while I have a lot of optimism that asteroids won't hurt us, I do not have optimism that humans here on the ground won't try to hurt us.
I remember there was a quote that I saw, and maybe it was fake, of an astronaut who, like, when they looked down on Earth from space for the first time, that the epiphany he had was like, man, it makes like all of our politics and all of our like the small conflicts that we're so fixated on like feel so insignificant. And
that's real.
Okay, that's real.
It's called the overview effect.
The overview effect.
Because you can't see borders.
No.
When you're up there, you can't see most human-made things. It seems more like a pristine natural environment when you're looking at it from space, which really drives home the idea that it's the one ecosystem we have and share with each other.
Wow. And it is so funny to me because I think that, like, you know, again, I'm just one person, but I do think about the fact that it's like more often than not, these conflicts that do get resolved with intense levels of violence, it feels as though there would have been a way to not do that. But like, I also like the human emotional experience is so complex, much like the chaos of space. And sometimes it feels like this cataclysm is the only way forward, but it doesn't. I just have never understood emotionally how you get to that place. Like, like imagine like we built this thing to protect ourselves. It's like, why would you turn around and look at it and go like, like what? I don't know.
Because you're a good person, Mayanna.
Oh my God.
That's why you can't think of it.
Thanks, friend. I try my best. But it is, I mean, it's good to know what's possible. I think like we all get afraid of, like, what if I get struck by lightning? What if a hurricane comes? What if it like, and there's a lot of things you can prepare for, but at a certain point, like there are forces beyond us that, you know, work with us and work against us, but they're neutral. Like what you said about the universe, like a tornado just does what a tornado does. The rain just does what the rain does. And it's so interesting to think about, like, what can we fight against? What can we live with? What can we survive in spite of? All that kind of stuff.
Yeah. Space inspires those questions for me.
Yeah. I hope Henrietta can take us home. Henrietta from IG. We would die if we entered a black hole, right? Just checking. You would not survive spaghettification.
Correct.
So if you go into a black hole, that's it. You're game over.
I mean, even before you go into the black hole, once you get to the accretion disk, like outside the event horizon, the gradient of gravity, so like the difference in gravitational force at your head versus your feet is so extreme that it rips you apart.
Wow.
And you cannot survive that. Like, it takes all of the individual atoms in your body and then streams them out in one long string, which is why we call it spaghettification, because you get stretched into a tiny little spaghetti noodle.
Wow, I didn't even know that was the real term for it. Wow, that's fascinating.
Mm-hmm.
God.
So no, could not survive that.
Yeah, that tracks. That makes sense.
Good check.
Yeah. Yeah, thanks, Henrietta. Thanks for looking out. I guess don't go in any black holes. I don't know if you were thinking about it. Don't do it.
That was not going to be my answer to her next question.
And then their follow-up question, if you could travel to another planet, moon, or world, what would you pick, assuming it's habitable? Habitable. Yes.
Habitable. Yeah,
habitable.
Yeah. I have 3 answers for you. I'm so sorry. I couldn't pick just one.
Ooh.
The first in our solar system, if I'm limiting it to that, is going to be Io. This is a moon of Jupiter, and it is the most volcanically active world in the entire solar system.
Is it just oops, all volcano?
Yeah.
Wow.
Yeah. I want to see all the lava.
Is lava one of your favorite kind of like natural phenomenon?
No, but I like superlative things. So the fact that it's the most
volcanic. That's so funny. It's like, you see Vanessa over there? She's the most from Wisconsin of anybody in Wisconsin.
Well, then I want to know Vanessa.
Her last name is Wisconsin. It's Vanessa, Wisconsin. That's okay. So you have 3 answers. So first, volcano planet. In our solar system. If I'm allowed to leave the solar system, then I'm going to go to Kepler 186f, which is a planet I studied in college. And it was the first, Earth-like world found. It's Earth-sized. It's in the habitable zone of its star. But its star is much smaller than our sun. It's a red dwarf star. And so I want to go to Kepler 186f to see if the grass is indeed redder on the other side. Because the tagline for Kepler 186f is that the grass is always redder on the other side because it orbits a red star. That's so sick.
And we call our sun yellow, but it actually does peak at green.
That's why our grass is green?
That's why our grass is green.
That's crazy. That's crazy. Also,
Yeah,
my
it?
desktop background is like a Bulbasaur in a very green forest. And so I just look at this greenery all the time. And it's like, yeah, so if we had a different star, we'd have like bluegrass or like purple grass. That's so cool.
Yeah. So there are so many interesting consequences of our sun peaking at green, plants being green.
Okay.
But then because we evolved in a very plant-heavy context, our brains are literally comforted by the color green. They've done experiments where they test people's heart rate looking at different colors. Green relaxes our heart rate and it helps oxygen flow. And we can also discern more shades of green than any other color because it was important for our survival in the jungle.
That's incredible. Oh my God. Well, because I remember all of the especially making your space cozy during the pandemic. It's like, get more plants. Get more plants. Put the plants everywhere. They're so healing, the plants. And that makes sense. That's who the infographic, when I see an Instagram graphic, that's the voice of all the Instagram graphics for me.
I was wondering.
Take time for yourself. Take time for yourself. Do a meditation. That's how they all sound to me.
It fits. Yeah.
Thank you. I'd say so. Okay. So what's your third answer?
My third answer is quite literally any rogue planet that I could land on in the Milky Way bulge.
Whoa. Do they move really? Are they hard to land on?
I just mean I don't want it to be a gas planet.
I see.
So a rocky planet in the Milky Way bulge, because that's an area in the galaxy where we probably expect there to be a lot of rogue planets because stars have more interactions with each other.
Oh, wow.
But I also think that the night sky would just look so interesting. It's a much denser stellar environment, so more stars are packed into a smaller space. So I think their night sky would just look really cool. And if it's a rogue planet, its night sky can change because it's not always around the same star.
Dang! That would be right. That's because that's rogue planet's whole deal, as we have discovered. Dang. If you could name a rogue planet, what would you call it?
Wow, hard-hitting question. I'm thinking of some sort of mythic influence. So I'm thinking of a character who, like leaves the crowd and maybe goes on some sort of adventure and doesn't come back. I'm thinking Odysseus.
Yeah, the road less traveled.
I'm thinking Calypso.
I
maybe
love
because
that.
Like the what's the opposite of abandonment when you're forced out?
Oh, ostracization or banishment.
Yes.
Yeah. I don't. It's so funny. There was a video game, a JRPG that I played when I was younger, and the two characters were like, we were ostracized, and I was like, whoa, big word. That's a big word for Elmo. I was like, wow, I don't know why this is how my silly little brain works. I just think of an ostrich with one of those like hitchhiker's sticks with a bag on the back.
But are ostriches the one who put their head in the sand?
That's an ostrich, yeah.
Okay,
But this one's ostracized because he wouldn't put his head in the sand. He was the free thinker. And so now he's forced to wander the desert.
I love the image of an ostrich with all those little packs.
And he's like...
on its non-shoulder.
I know, just like... Meh. This is the world I live in.
Yeah, it just goes meh, and then it lays a giant egg, and then it walks away.
And it goes meh, meh, meh. And then it cracks open with a little baby, and then it also has a baby little hitchhiker stick with a bag on the back.
Because that baby was born to this life.
The baby was born on the road.
Incredible. Oh my God, I love this so much.
Thank you. I do my best.
Oh, do you have any lingering questions after all of that?
I know it's kind of like a roundabout question, but like, were there any questions you were hoping somebody would ask that they didn't, that you really were hankering to answer?
Well, I always like more planet questions. So that's why I put the, like, what's your favorite planet question at the end.
Ooh.
But anytime I get to talk about Kepler or exoplanets or habitability, like, I get really excited.
Okay.
So that's nice.
Who is the bad boy of our planetary system? Who's the bad boy planet?
Ooh, bad boy planet.
Who's the bad boy planet? We're in bad boy land today. Jack Bowler really got me thinking about it. Yeah, who's the bad boy planet?
My first instinct was to go to the outer solar system.
Which makes sense.
But I think I'm going to go inner, actually. I think I might want to go, like, Mercury.
Ooh, say why?
Because it's hot-tempered.
Yeah.
And we don't know much about it. It's kind of mysterious.
And mercurial is like this unpredictable quality, right? You don't know what he's going to do next.
You don't know. And it's disappointing in a way. Like, it's very hot. Mercury is very hot. But it's not the hottest planet in the solar system. What do you mean? You should be.
Yeah.
And that's how I feel about bad boys.
Because they're like, you're like, I get it, but also like,
Like, if you're gonna be bad, you really got to take it there. Like, you got to be a caricature.
Yeah,
of
you have to
basically.
You have to be like Kylo Ren on a jetpack, smoking 3 cigarettes at once. If you're gonna be a bad boy, you got to take it all the way to the bad boy horizon, and everyone's too afraid.
You got to take the risk.
And then who's the good guy planet? Who's the goodest guy planet?
That's Jupiter.
Jupiter.
I'm going to give that to Jupiter right away. In conversations about what makes Earth habitable, when you get really expansive, you start to think about influences from other planets. And it turns out that Jupiter is so massive and so good at attracting things like asteroids and comets to its own body that it kind of takes a lot of heat away from us.
Oh my God. Jupiter's like the friend that was there all along. And like you didn't know that someone at the party was talking shit, and they're like, "Don't you say that to her." That's Jupiter.
That's Jupiter. Yeah, Jupiter's the big brother planet. Have you ever seen the movie Labyrinth? Yeah, with David Bowie. Jupiter is like Ludo, the rock collar character, just this big, fuzzy, lovable creature who's calling all the rocks to save the rest of the party.
Yeah, that rocks. I didn't mean for that to be a pun, but it is.
It worked.
Ludo. Yeah, that
Ludo.
feels nice. I like that.
Thank you for those questions.
Thank you all the people who submitted questions. They were very fun to read out loud.
Yeah, thank you. I'll do another episode like this because this was fun.
This was so fun.
I like hearing from y'all. I have a question for you, Mayanna.
Go for it.
Okay, well, your gas made me think that I should do an exciting one now.
Oh, no, I'm just excited. I just get excited about everything.
I was going to ask you, what you're working on and how people can find you. But now I want to ask you an exciting space question.
No, please. That's a perfect question. I'm Mayanna Berrin. You can find me on Instagram at Mayanna Berrin. You can find me on Blue Sky, I believe, at Mayanna Berrin. I actually don't really... The Blue Sky handles confuse me. I'm still working on it.
Why are there so many dots?
So many dots. You can find me on Story Quest. And our first campaign is called Supernova because it takes place in space. We're using the Spelljammer 5e system, so it's very fun. There's space pirates in there and lots of Treasure Planet inspiration. So if you like space stuff, we are a silly little show about aliens. Nothing is factually accurate. You can also check me out on Tales Unrolled. Keep your eyes peeled for updates on that. And also, I am a video game writer, and please wishlist the video game Dispatch on Steam. I'm one of the writers on it, and I'm very proud of it.
Yay! What was it like to work on it? What was the best part for you?
Oh, best part? Oh my gosh. Okay, so there's a huge cast of these sort of superheroes, but they're all kind of like snarky. And so, my main job is figuring out how they interact with each other in gameplay. And so like it's a workplace comedy. And so you're in the field and like who's friends with who's got beef with who. And I don't know if you played like Baldur's Gate or anything, like when you have the characters walking around on the map, they'll have these little banters that they'll just say as you're like traversing the space. And so that was my main job, was writing a bunch of those, like all these little conversations between these superheroes about mundane, silly things. And so it was very fun. I got to put a lot of jokes that my like friends inspired, or little isms that people in my life would say. So I got to just inject a lot of just fun, organic, lived things into these characters. And they really came to life, and I'm so proud of them. I can't wait for people to meet them. They're so silly.
I'm so proud of them and of you.
Thank you.
Secondhand.
Thank you.
Your face lit up when you talked about it. So that was really nice to see.
It's been my dream since I was like 11 years old to work on a video game. And so I have been very grateful, and it's been such a wild road to get here. But yeah, so I'm proud of it. Yeah.
Aw. My cheeks are red.
Yeah,
that's
good.
a perfect place to end. Thank you so much for coming to my office and going through these questions with me. I really appreciated the back and forth here.
This is so healing for me. Thank you so much for having me back on.
I have to go proctor an exam. There are a bunch of like 20-year-olds waiting to be very stressed.
Well, thank you so much for having me in your cozy office. This was so great. It was kind of fun because like you were at your desk and I was sitting at like the chair across from you. Like we were getting a little bit like academic advisory, but it was just a fun little chit chat. I love meetings that just turn into a fun little chit chat. It's one of my favorite pastimes.
Me too, especially when you can do it in a plush, comfy office. This is the side of the ivory tower more people should know about.
Agreed. Absolutely. I love a light academia vibe.
Oh, yes. Well, no matter how illuminated you want your academic vibe to be, listeners, remember you're still space.
Oh, I forgot. Thank you for reminding me.
Pale Blue Pod is hosted by me, Dr. Moiya McTier, a.k.a. the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.